We have section 5.5, differentiation of logarithmic functions. So the derivative of the ln of x is 1 over x. So whatever that argument is, it's going to be taken down and it'll be in the denominator. And x cannot be 0. So some examples. We have f of x equals x times the natural log of x. We're going to need to use the product rule for this. So f prime of x times ln of x, that derivative is 1 over x, plus ln of x times the derivative of x, which is just 1. So this simplifies to x times 1 over x is just 1. We get 1 plus the ln of x. Another example, g of x is ln of x over x. So I have to use the quotient rule. So my g prime of x is denominator times the derivative of ln of x, which is 1 over x, minus the numerator times the derivative of that x on the bottom is 1. And then you square your denominator. So x times 1 over x is just 1. Ln of x times 1, we get minus ln of x, and that is over x squared. So just like when we talked about the derivative of exponentials, when we have some other function in here for the logarithms, we have to make sure that we're taking the derivative of that as well. So we have to make sure we're using the chain rule. So d dx of ln of f of x. So now it's not just an x, it's a function. What we're going to do is take the derivative of that function and put it in the numerator. And just like when it was just ln of x, we take that function and put it in the denominator. So it's f prime of x over f of x. So my first example with this, I have ln of 5x squared plus 7. So that's y. So y prime, I'm just going to rewrite that 5x squared plus 7 exactly as it is. It goes in the denominator. And the derivative of 5x squared plus 7 is 10x. So that goes in my numerator. So here is pretty long. So this derivative could be really messy, but because it's a logarithm, I can use the properties first to break it apart and then do each smaller term, take the derivative. So I know where there was a multiplication, it becomes an addition. So I have ln of x cubed plus 1 plus the ln of x to the 5th minus 8x. And that 5 that was an exponent, remember that property, it gets multiplied out front. So I'm going to have a 5 right there. Now when I take these derivatives, they're not that bad as opposed to trying to do it all together. So y prime, this first term, the x cubed plus 1 goes into the denominator. Derivative of x cubed plus 1 is 3x squared. For this next term, I have that 5 out front, so I'm just going to stick it there. X to the 5th minus 8x goes on the bottom. And then the derivative of that, 5x to the fourth minus 8, goes on top. So when you have these logs, it makes the derivative so much cleaner. And if you don't have a log, you can introduce it yourself so that you can actually make the problem simpler to take derivatives for. So this problem doesn't have any logs in it, but I'm going to introduce logs so that we can take the derivative a lot cleaner. What we're going to do is first take the natural log of each side, then we're going to break it up using the properties. We're going to take the derivative, and then lastly we're going to solve for dy dx. And these are all typed up for you in your notes, so make sure you have those out. I have the steps typed for you. So the first thing is to take the natural log of both sides. So on the left here, it's just the natural log of y. And on this side, these are the three pieces that are all multiplied together. So ln of x cubed, I'm going to multiply that 3 out front. So 3 ln of x plus the ln of x squared minus 5 plus, again, this piece has an exponent, so I'm going to multiply that out front. So 3 ln of x plus 4. Now that I have it all in smaller terms, the derivative is going to be a lot quicker. So this ln y, remember when we did implicit differentiation, if we have a y, it is a function. So when you take this derivative, the y goes on the bottom, but y prime is going to go on top. Equals, this first term is just going to give me 3 over x. This next term, the x squared minus 5, goes on the bottom, and the derivative of that is 2x, so that goes on top. And this last one, I have that 3. And then the x plus 4 goes on the bottom. Derivative of x plus 4 is just 1. So I'm done with that. So can you imagine taking the derivative, having to use the product rules and chain rules up here versus what we get down here? Last step is I need y prime by itself, or dy dx by itself, whatever notation you're using. So I'm just going to take and multiply both sides by y. So my derivative is done.